This lesson will teach me to solve a system of equations by substitution. A system of equations is defined as two or more equations together. The solution to a system of equations is the ordered pair that makes both equations true. One method of solving a system of equations is by graphing. You would graph both shapes and you would see where they cross. In this case, we're going to solve using substitution. Substitution is the idea of taking one thing out and replacing it with an equivalent. First thing we need to do when we solve by substitution is to get a letter by itself. Usually we think about getting y by itself, but we could get x by itself depending on the situation. So for this particular problem, I see that I have a y equals, but I also see that I have y minus 30 equals 12x. So if I can get this y by itself, then I can take out this one and replace it with its equivalent. To get the 30 to the other side, because it's being subtracted, I'm going to add it. So y equals 12x plus 30. Now that y equals 12x plus 30, I'm going to take out the plain y, and in its place, I'm going to replace it with what it's equivalent to. So 12x plus 30 is now equal to x squared plus 11x minus 12. This is the idea of substitution. Now we need to solve this quadratic equation. I have the x squared here. So I'm going to move the 12x, and I'm subtracting because it's a positive, over to join its friend, the 11. So I now have 30 is equal to x squared minus 1x minus 12. And if I can get this to become a 0, then I can solve the quadratic equation. I'm now going to move the 30. I'm choosing subtraction because the 30 is positive. So I have x squared minus 1x minus 42, and it all equals 0, and the 0 can go at either end. You have several ways of solving a quadratic equation. We can factor, we can graph, which in this case we're not graphing. Square roots won't work because of the x here, or you could use the quadratic formula. I'm going to choose factoring because I can do it quickly. I'm looking for things that multiply to give me negative 42, that add to give me negative 1. I know the numbers are going to be 7 and 6. I'm going to go back for my signs. So 0 is equal to x minus 7 and x plus 6. Because they're both these small equations, I can set them equal to 0. Add the 7 to either side, subtract the 6 from either side. So my solutions are going to be at 7 and at negative 6. What we've done is we've solved the quadratic equation. So that means one of my answers is going to cross at 7. The other answer is going to cross at 6. I need to plug these values in. So if I take the 7 and you can put it into either equation, I'm going to use this one. And if I do 7 squared plus 11 times 7 minus 12, grab your calculators. I get 114, 114. Then I can go back up to this equation and I can do negative 6 squared plus 11 times negative 6 minus 12. And it gives me negative 42. So if we were to graph this one right here, which is a line, and if we were to graph this one right here, which is a U, they would cross in two places. One of the places would be 7 and a positive 114. And the other place that the two shapes would cross would be negative 6 and negative 42. So the steps that we did, we needed to solve to get a letter by itself. We substituted a letter out for an equal expression. And then what we needed to do last was we needed to plug the x values into an original equation to solve for y. and making sure that answers are always written as ordered pairs. And ordered pairs, oops, that's an I in there, are always an x comma y and an x comma y. So we found an x value, we plugged it back in, got 114, found the other x value was -6, plugged it in to get the -42. If you don't like factoring, you always could use the negative b plus or minus the square root. You could use this whole big one, 2ac. That, when you have plugged in all the numbers, would have also given you x was 7 and x was -6, and you still would have needed to plug them back in to get those values. All right, so let's see here. We need to first get a letter by itself. Well, I see y equals and I see y equals, so we're okay there. I'm going to take this and I'm going to substitute it in that place. So take out the y, and instead of writing the y, we're writing what it's equivalent to, equals x squared minus 6x plus 10. I need to get the equation in standard form. Notice how it looked here so that I can solve it. I'm going to move the x by addition because it's already subtraction. And while I'm at it, I'm also going to move this 4. Notice the 4 is positive, so I undo it with subtraction. So these have canceled, so I'm at 0 equals x squared minus 5x plus 6. Now that it's in standard form, I can go ahead and solve. You can solve using your product sum circle to get it into factored form, or if you'd like, you can use the quadratic formula. I'm going to find things that multiply to give me 6, that add to give me -5. Well, 6 is made up of 6 times 1, and let's see, this one, nope, I think I got the wrong values here. If I were to do this, that's going to get me a -6. So what if I try 2 times 3, and if they were both negative, that would add to give me -5, and to multiply to give me a +6. So I found my values here. 0 is going to equal x minus 2 and x minus 3. Due to that thing called the zero product property, that's what allows me to set each equation equal to 0. So that means x is now going to be 2 and x is going to be 3. These are where the two things are crossing. So again, this is a line and a U shape, and they're crossing at 2 and 3, but I need the y values that go with it. So 2 comma what and 3 comma what. So go back up to either equation, it's totally up to you. The equation that I'm going to pick is going to be this one right here, the linear one. I'm choosing this linear one because it's the simplest. My answers were a 2, so what's 4 minus 2? 4 minus 2 is 2, so when I plugged in a 2, out came a 2. Let's try it with our other answer, which was a 3. So I put that here. 4 minus 3 is 1. So my two answers are 2, 2, and 3, 1. So that means that when you take the U-shaped graph and when you take the line, which I think technically that line is going the other direction, but when we take the U-shape and when we take the line, they're crossing in two places. It's crossing at 2, 2 and at 3, 1. All right, and I think we have one more. It says Justin is skeet shooting during the Olympic trials. The height of the skeet is modeled by the equation. Okay, so here's my little clip art thing. So here's the gun and here's the thing that they're shooting. So this is where they say pull, and the thing kind of shoots up that plate behind them, and then they try to shoot it while it's in the air. So the projectile, it says the height of the skeet is modeled by. So we have thing gets catapulted up, but at the same point, the shooter is standing with his rifle, and he's trying to shoot, and he's shooting in that linear fashion. So we want to see where they're going to meet. So the curve is -5t squared plus 32t plus 2. It says where h is the height in meters after t seconds. So that 2 says that it's starting at 2 meters. It says the path of Justin's bullet is modeled by the equation. 31.5t plus 1. So if I go back and redraw this diagram here real fast. All right, let me see here. So we have that little plate skeet thing, starts at 2 meters and is coming up, and then will eventually hit the ground, I guess, if it doesn't get shot. So this is in seconds, and this is height, which is in meters, right? What's it say? Feet. Seconds, height is in, yeah, in meters. Okay, so it's in meters. So it says that it's starting at 2 and it's getting launched up in the air and then coming back down. At the same time though, it says his bullet is modeled by, so he's starting at 1 and it's being shot upward this way, and we want to know how long will it take for the bullet to hit the skeet, assuming he aims correctly. So this is essentially a y equals, and I guess you really don't even need that. And this is essentially a y equals, but if you notice they each have the same heading. So because they each are equal to h of t, I can set them equal to each other. So I'm going to take this 31.5t plus 1, and I'm going to replace it in for this one. So it's going to give me 31.5t plus 1 equals negative 5t squared plus 32t plus 2. I'm going to get this all over to the right-hand side. So I'm going to move the 31t by subtraction, and I'm going to move the 1 by subtraction as well. So now this is all 0, and I'm at negative 5t squared plus half t plus 1, and it all equals 0. I'm not going to be able to factor this, so we're going to have to use the quadratic formula. So the opposite of b plus or minus the square root, oops, I should be probably using decimals for ease, b squared minus 4 times a times c all over 2 times a. Oops, 2 times a is going to give me negative 10. I just want to fix, let's use decimals, it's probably easier to enter. So the opposite of b. When I type in the stuff underneath the square root, I ended up with a 20.25, and I just entered this, all divided by negative 10. When I entered that in my calculator, t ended up being negative 0.4 and 0.5 seconds. So there is really another piece over here, but it doesn't mean anything. So neither does that. So after half of a second, so half a second is way out here, they're going to meet. But I want the ordered pair. So it says, how high off the ground will the skeet be when it's been hit? So we found the amount of time that it's going to take. So if we were to plug that 0.5 into either equation, either to the quadratic or into the linear, we're going to find that height because it's where they meet. So again, for sake of ease, I'm going to put that 0.5 that I found into this linear equation. 31.5 times 0.5 plus 1. That height is going to be, when I typed all that in my calculator, it gave me this height right here. It gave me 16.75 meters. So the ordered pair is after after half of a second, can't have a negative second. After half of a second, it has gone 16 meters and a little bit more. So that's really what it wants here. How high will it be? 16.75 meters. Thank you so much. Do the best you can and let me know what questions you have.